Hello, everyone. Welcome to our webinar, GS18 I, How GNSS with Visual Positioning Changes the Game for Surveyors. I'm Christine Grail, and I'll be your moderator for today's session. I don't know about you, but I am a big fan of what-if questions because of how they remove all the limitations and barriers. Asking what if compels us to think creatively and challenge assumptions. And so the question we are posing today is, what if your GNSS rover, RTK rover, could see? And the reason we're asking that question, The reason we're asking that question is because a few weeks ago, Leica Geosystems launched the GS18 I, the world's first GNSS RTK rover with integrated visual positioning technology. This is an incredible advance in GNSS technology because the sensor fusion in the GS18 I allows you to measure hundreds of points in minutes, reach previously inaccessible points, and capture points from a safe distance, all with a remarkably simple workflow. Essentially, the GS18 I GNSS RTK rover can see. But what does this really mean for surveyors? And what does it mean for your business? Our team of product managers and support engineers here in the US and Canada didn't just speculate. They took the GS18 I out into the real world and put it to the test on several applications that have previously been limiting for GNSS. Today, we're going to walk through some of the most common questions we've received about the GS18 I and show you some of our own discoveries on the what-if journey. Our Q&A panelists today are Bob Kilburn, Ted Miller, and Tim Kerr. Bob, why don't you go ahead and tell us a little bit about yourself?
Bob Kilburn. I've been with Leica for about 5 years now. Previous to that, I worked for another manufacturer. Before that, my history in the industry goes back 24 years. I started out as a field artillery surveyor and worked my way up from the third man on a crew to be a crew chief before I started doing tech support training and product management.
Okay, excellent. Ted, what about you?
My name's Ted Miller. I've been working with Leica since 2008. I've had the pleasure of working in tech support and product management, and currently I'm in software management side of Leica. I've been a surveyor since '91 and have spent about 10 years in the field of photogrammetry.
Okay, and last but not least, Tim Kerr.
Okay, well, all my young counterparts here, I started surveying in about 1970. Joined Wild Hairbrook in 1985, and I've been with the company with a few brief intermissions ever since. I've fulfilled a lot of capacities, including product management, marketing, managed our mining group. Now I'm back into our technical support and training team. So it's been a very long, interesting adventure.
Excellent. These are definitely the guys you want to reach out to if you have any questions. They certainly know their stuff. I want to say that also on the line with us today, we have Pierre LeBay, who is our survey segment support manager, and also Burke AC, who is our technical support specialist. And these guys will be answering your questions behind the scenes. Now, we want to get started addressing some of the most common questions we've received over the past few weeks. If you do have additional questions about the material being presented, please go ahead and type those into the questions box that you should see on your screen, and we will address as many of these as we can throughout the presentation. If we are unable to get to your question in the live session, someone will reach out to you after the webinar by email. As a matter of introduction, let's go ahead and tackle the very first question, which is just the basics. What is GNSS with visual positioning? Bob, can you give us a bit of an overview?
Absolutely. As you'll see, it's true sensor fusion or merge technology is what visual positioning is. So this is integration of GNSS. It's our IMU, which is an inertial measurement unit. And then we have the visual or imaging sensor, all combined with the processing that is going on inside the receiver, then also Leica Captivate, which enables us to actually create and digitize points in the field in near real time, and then also in the office inside of Leica Infinity. In this next video here, we just simply show what capturing an image group looks like. So you'll see, if you're familiar with measuring a point, you just start measuring an image group. You start walking, and we're collecting those images at a rate of 1 image every half a second. In the next slide, we have another very quick video to show you what measuring a point or a feature selection inside of Captivate. So this is in the field. We can then go into the image group. We can move through until we find the image that has the feature that we would like to select or create a point on. We're going to go in here. We're giving it a code. I also have to give it a point number because I didn't have my auto point numbers on. So we do that. Then we select that feature inside the image. We can move that selection to where we like it, and we tell it to measure. It'll come up and give us the 3D quality and tell us how many images were used if it meets our QC value that were predefined.
Okay, excellent. Now, I know a question that I've seen come up several times is with regard to the sensor. I know we've all seen sensors in the past that have had some form of imaging. So can you tell us how the GS18 I is different from what we've seen previously?
It really goes back to what I was saying earlier with the true merge technology or sensor fusion. And this quick video here shows that all coming together. So it's the IMU, it is the GNSS, and it is the imaging sensor, which is capturing. And in this case, we're truly dynamic, where anything we've seen in the past has been truly a static photo or image processing. Now we're doing it dynamically. So we're capturing these images with the true sensor fusion that's going on in the background. If you'll notice here, if you're familiar with our RTC 360, this looks very much like the Viz technology that is used there to position the sensor. So there we're using several cameras on one sensor to help position the sensor. In this case, what we're doing is we're using that same technology to be able to identify all the objects in an image from one image to the next. So that's how we can, the software can automatically go select the same feature that you pick in one image and then calculate those intersections for you. So in this slide, we're showing you what that sensor fusion looks like and what is going on. So as we move, we collect each image. Because we have an IMU and a GNSS, we can put not only the XYZ, but the pitch even roll that allows us to position that sensor with that image with 6 degrees of freedom. Therefore, when we select a certain feature that we would like to measure to, it will go to the other images, pick that same pixel or feature in those images, and compute the intersection and create an XYZ at that point for us that we can also code separately.
I think what a lot of people would want to know is what is the operating vision distance and range of precision with that information?
So we have a 1.2 megapixel camera, and we need to, the object of capture needs to be within 2 to 10 meters of the instrument. And then the accuracy is 2 to 4 centimeters two-dimensionally and 3 to 5 centimeters 3D.
Okay, and what about the light conditions? Do we need a certain level of brightness to be able to achieve that kind of accuracy?
The brightness we have to be able to, and the imaging sensor has to be able to see or detect the feature that we're trying to extract, right? So because we're using image, think of it as seeing, and if you can't see it with your eye, the imaging sensor is not going to be as well. So there is a component of deep shadows. It could be bright sun going right into the imaging sensor. So there are some things that come into effect there, just like your eye. If you can't see it looking at those angles, we have similar problems.
Okay, that makes sense. Now you talked about the RTC 360 and the Viz technology. Of course, that's laser scanning or LiDAR. And so I think a lot of people probably want to know if the GS18 I is a replacement for LiDAR. Tim?
Yes, that's a great question, and it comes up quite frequently, Christy, and absolutely not. As with any surveying technology, the application is, or the result is really driven by the requirement of the application. So there's cases where we need the high precision modeling grade point clouds, which we get from the LiDAR solutions, like the ScanStation P series or the RTC 360, or on the surveying end with a versatile scanning total station like the multi-station. The dense point clouds that are derived from the photographs acquired with the GS18 I in the GS18 I image groups we would think of more as a mapping grade quality type solution. And these are about the quality of a standard RTK positioning quality. They're a great aid in the visualization of the project in and of itself, as we'll see illustrated by some of the examples that Bob's going to show us as we move forward in some of these, as we move through our session. These could include, things like mapping of obstructions, volumes for trenches, stockpiles, and we'll certainly discover a lot more areas of application as we move forward. The dense point clouds that are generated are of great value on top of the ability with this system to, extract either in the field or through the office discrete points that we couldn't get with, conventional GNSS RTK techniques. So, it's certainly not a replacement for the LiDAR. It's an enhancement and a different method that we can utilize. Next, we'll take a look at a kind of a comparison and contrast of the results of these. And what we've got here is just a brief example, first showing a GS18 I point cloud that has been processed at full resolution. And we can see that we've got a pretty clear, pretty nice point cloud there. It is a little bit grainy, but we kind of, would kind of expect that as well. When we look at the second one, we'll see that this is some point clouds that were taken with one of the multi-stations. Here we've got a true LiDAR type image where it's much sharper, crisper image, which is what we would expect because we're using a little bit higher precision than pulling off of the photographs for the point clouds. And on our final view here, if we overlay the two, we can see that they overlay very nicely. They fit well with one another. And you'll notice down towards the front area there that you can see there's a little bit of grass. It actually shows from the photo point clouds. It wasn't showing in the LiDAR type solution. So, it's, you see a little bit different view of things depending on the type that you're using. And once again, to summarize, it really depends on what you need to deliver to your client, what could be the right solution.
Excellent. Thank you for that overview. Now, because we're talking about photogrammetry, I think people immediately are a little bit concerned about whether they'll need any kind of special knowledge. In the past, when you've worked with photogrammetry, in some cases, you need a photogrammetric scientist on staff to be able to handle the data. And so with the GS18 I, do you need any special knowledge to be able to process the data coming off of that sensor? Ted?
Christy, well, the short answer is no. So while photogrammetry in a broad sense is just measuring points from a photo, the traditional computations and the procedures to measure those points is quite complex. So if you can see in the top workflow chart, the steps needed not only include introducing control, but also has various steps orientate to each photo so that the points are in a common coordinate system. That's all done before you can even measure a single point. In the flow chart below, you can see the GS18 I, the coordinate system is already corrected just by common GNSS practices, and all the complicated orientation computations are processed inside of Captivate automatically. So this gives the user the ability to measure these points from the images immediately. They don't have to go back into the office and do all these complicated orientations, exterior, interior, and they can measure them as soon as they're captured and processed in Captivate, and whether that's in the field or in the office.
Excellent. That ease of use is so important. So what is the primary value of the imaging capability in the GS18 I? Bob?
So it really comes down to being able to measure what you can see and not what you can touch. Many times we carry additional tools to the field with us to overcome or to add on to the limitations of traditional GPS. So we might have to set up a robot, not because we're completing a traverse or need enhanced accuracy. We're doing it to overcome a limited view of the sky or something else where that GNSS grade measurement would be more than good enough, right? So with that, we start off with the safety component. There's no replacing or no substitute. When you have the ability to do something safer, that's always got to be the first consideration. So removing that surveyor from that field of influence of danger, whether it be a roadway or a ditch, as in this example here, where we see him overcoming some of the challenges we would have had in the past by using the GS18 I. Now with the I, we can move outside the fence. So not just outside the ditch, but outside the fence, that area of influence, and really increase the deliverable at the same time. So we're being safer and we're increasing what we could deliver to the customer by documenting this with the imaging, being able to create point clouds and measure any of those crossing utilities in that fashion. Next, we go on to maintaining that survey grade accuracy, the GPS accuracy, when you have overhangs in covered areas. Traditionally, if we were to set up a robot here, we're in a bus depot, we know that there's going to be a bus. If you ask a surveyor, there's going to be a bus that parks in front of you, guaranteed. It's just Murphy's Law. If we try to overcome this measurement scenario by pulling offsets, we introduce another component of the human error and the compounding of that error when we start measuring and creating offsets. So being able to do this with the imaging capability is going to be a great advantage to our customers and their customers. We go to the productivity component, which we just talked about kind of in both of the previous two, because it is a matrix or a component of the safety and of the accuracy. So, but also there's another level of communication that's always struggling, no matter what organization you're involved in. What does the engineer need? If you look at the building corner there, we have a wood facade below, or we have some type of stucco or mortar up above that. What is the building corner? Which one does the engineer need? How much time do we take defining that and recording it in the field? And how do we record it? With the imaging sensor, we can record the image group and the engineer can decide what measurement he needs, and he can extract that right in the office without taking all that additional time. The same with the intricate stairway there. Defining that and why we're defining it kind of goes back to what Tim was saying of what is the deliverable to your customer. Is it just verifying for an Alta survey that the rise and run of the steps meet a municipal or a building code, or do we need a high level of detail that can be used for additional engineering or architectural expansion? And then the time savings, and this one is true, again, it's really a combination of all the above. The time savings in this type of scenario for our public safety personnel, let them thoroughly document an entire site without overlooking or worried about missing evidence, at the same time speeding it up, not for an economical point of view, but truly for a safety, well, it's a safety and an economical, because we have the safety value of secondary and tertiary crashes that inevitably happen when you start blocking traffic, especially if you take it off of a rural scenario here and you start putting this onto a highway or an interstate. Then you also have the economical component of the longer an interstate or a highway is shut down, impacts commerce for all the people that are being serviced by that major artery to their economic system, right? So these things all add together. So by being able to maintain the completeness of the survey, but doing it faster is of value to everybody involved.
A lot of great benefits. Obviously, we're increasing efficiencies and safety and so many good things here. I have to wonder, with the bringing together of all of these different sensors, is the GS18 I actually a replacement for total stations in some cases?
No, when we go to the next slide, we have another animation that I'm a huge fan of, and this lets us look at that. It could be in certain areas we no longer need to use a total station, but again, we're not doing that for an accuracy component. Was not the purpose of getting the total station out. It was to overcome the view of the sky or some other limitation that was covered by the GS18 or 16. So if you saw in that first one, even the little trees were blocked. Now we add an IMU to the GNSS sensor, and we could get under the smaller trees, or we could get closer to the building. By expanding that to the eye, this entire site becomes measurable from the GS18 when the accuracy requirement is of GNSS grade and we're not doing some kind of closed traverse or something like that. So it's not replacing it for the accuracy demands of a total station, but it could be just in applications that it was used because of a limitation of the older GNSS technology that was out there.
Okay, so it certainly makes it easier when someone's going out in the field. You know, maybe they only need the 18i in some cases. Again, that project planning is so key, and knowing what you're trying to get out of it. I know that when you guys first got your hands on the 18i, one of the things that you wanted to explore was what new opportunities this might create for surveyors. And so what I'm curious to find out, and I'm sure our audiences as well, is what your discoveries were.
So a couple of use cases like we looked at earlier in the trench surveying, being able to document that in a new and different way, create a new deliverable, and it'll make it faster and more economical. And in this case here, we're also exploring the ability to measure and document rooftops with images for the design and construction of solar arrays. This is a huge push for all of us looking at becoming more efficient. Solar is becoming cheaper and more applicable, and then there's government subsidies and different things. So being able to as-built this roof for the ability to identify this, and this is a place where we kind of cross over. This can be done with drone technology, and we can extract these images. But what we lose there with a drone is the oblique view. We bring in government regulations of being able to have the 107 component to legally fly and operate a drone, and we don't have the oblique views of these components. So if I'm meeting with customers, if I can take a GS18 I and spend about 10 or 15 minutes walking this roof, and then come in, create that dense point cloud, and then I can digitize single points and measure those units and document the area that I have to work with and design a solar array. Is this something that you could deliver to that market as a surveying firm, as an engineering firm?
And is this Captivate that we're looking at right now, Bob?
Yes, that was in Captivate. So what we did was that is in Infinity. We captured this in the field with Captivate, and then we brought that into Infinity, created the dense point cloud, and then we went and created all those static points at the corners of the different units inside of Infinity.
Okay, great. And that leads into another question, and that is what happens when you bring the data into the office. You've already covered that a little bit, but I think you have some more to show us.
I do. In this next one, I have another quick video that just shows the actual feature selection in the office. So we have our image group highlighted. We just scroll through those images until we find the feature that we'd like to digitize. We zoom in on that. In this case, we're digitizing the center of this paint stripe at the flag line of the curb. We simply select it. It goes, looks at the images around the one that we just selected, computes the inverse and computes the point with coordinate quality displayed for us. In this next example, we run through. I actually select a point that the automatic picking does not work on. So we pick a point and it doesn't automatically go to the images or able to select it. So now I can manually do it. So now I move to a different image to create my geometry. I pick on the same pixel, it gives me my 3D coordinate quality. I add a third vector to this, and then I create the point. So this is one application, and this is simply creating points. We have no point cloud here. I just created the points from the images that I saw or felt I needed.
Okay, excellent. Tim, I'm wondering if you've had a chance to look at any of the questions. I know we've had quite a few coming in. Is there anything that we should stop and address at this point?
Okay, yeah, there's a couple. One of the questions was, does this tie into staking with the imaging? And not at this point in time. The staking is certainly tied in with the tilt, and we can stake with the tilt compensated values, but there would be no correlation at this point in time with the imagery. A couple of people brought up the point that this is also a good application to fill in with the drone technology due to restrictions that you may have with regard flight rules and that type of a thing, where we can actually fill in some areas where we may not be able to get that type of information.
Here's a good one right here, Bob, regarding accuracy. Is it fair to say the accuracy of the photo taken depends on the accuracy of the GS18 I at the time the photo was taken? So the positioning component.
It absolutely does, and all that is displayed to you in your image group. So the system is constantly measuring 30 random points in every image using that viz technology. And then when you process your image group, it takes into account the GNSS quality and the quality of your IMU at the time that that picture is done. And that's displayed in as a component of the overall image group quality. And you can set that quality or choose not to accept an image group, and this is all done in the field in real time. So you know the quality of that or what to expect from those individual measurements just by capturing the image group itself.
Okay, excellent. Let's go ahead and just address the key takeaways. I think there are probably a few more questions that we need to address. So maybe Tim, you can take a look at those, or Kier or Burke, if you're on the line, and could just let us know if there's any questions we should address for the benefit of everyone in the audience. In terms of the key takeaways here.
So there's some more on
Right
this
here.
video. That video was stopped.
All right, that's okay, we've got it. Okay.
Yeah.
So, Bob.
Christy, for the moment, we're pretty well caught up with questions, so.
Okay, excellent. Well, let's go ahead and run through the key takeaways. And then I just wanted to highlight one other thing about the Infinity software, because one of the questions that was just asked hit on something that I think we should mention. But for right now, the key takeaways I think that we want everyone to understand about this technology are first and foremost safety, right, Bob?
Correct. The increased safety can never be overstated, and the ability to do that and to provide that for our employees and our colleagues is always going to be an utmost consideration when we're looking at how we do products or projects and how we create deliverables for our customers. Maximizing the efficiency. This is the efficiency I hear all the time, that I've got not enough young surveyors, I can't hire enough surveyors, I have more work than I have to do. So can we increase the efficiency and the bandwidth with your current staff by adapting technology and creating more bandwidth to take on more projects and to deliver deliverables in a, that's a great way to say that, right? Deliver deliverables in a more creative way. And all this goes to expanding your business, generating more revenue for you so that you can continue to grow and create great things for your customers and their customers. And then owning that data, being able to collect so much rich, detailed data Similar, this is a similar ROI compared to the scanning at a different level, of course, but you own that data once it's collected. So if you can collect data and reduce, this goes to efficiency, reduce having to make a remobilization to a site to augment something that you are already there to capture, or if the expansion or size and scope of the project grew, if you had that data, even inadvertently captured in the first time, you can mine that and resell it, and that's okay. That will increase your revenue because you're adopting technology to be able to deliver and extract those things.
Okay, excellent points. Now, one of the things that I know I've seen before, questions that have come in about being able to quality check the data and make sure that you've got the accuracy and do the reporting that you need. Really, that's a tool, that's a place where Infinity comes into play, right, Bob?
Absolutely. Being able to create reports and check all your accuracies and precisions inside the software, make any edits that may have been made, fix blunders is a critical component to surveying as a whole.
Okay, that makes sense. I know we've continued to have questions come in, so let's go ahead and address those at this time. I think we had one here about the controller and what type of controller has to be used with the GS18 I.
So with the GS18 I, we have the CS35, which is our tablet controller, or we have the CS20. Now on the CS20, we've had two different variants since that was launched, and we need the most current one. So the one that was launched, there's actually three in that basket, but it's the LTE variant that was about a year ago that was released, has 2 gigs of SD RAM that allows us to process these image groups. And that's why it's required in that collector.
Okay, excellent. And we highlighted the Captivate software in the field and the Infinity software in the office. Do you have to get the whole package to get the benefits of the visual positioning with GS18 I?
That's part of the brilliance of this is you don't. If you don't need the office component, you're going to digitize a few points in the field, if creating those from image groups. Now, we're still going to recommend you have Infinity for your standard surveying QA QC process. But if you don't need to digitize points from your images in the office, and you can do that right in Captivate, then you can stop there. If you do want to be able to create those points from images, but you don't need the point clouds from the imaging, then you can add that component to your Infinity and just digitize. And this is a faster way to create those points. It's definitely a little bit smoother, and you have more real estate, a bigger screen, you have a mouse, things like that. So it's going to be an easier way if you're going to do a lot of production work. And then we can grow that one step further by adding the component of point clouds from images that will allow us to have that 3D realization. Even if we're not modeling the entire site, it lets us see that point cloud and helps us relate to the site and the environment.
Okay, excellent. I'm sure we have a few more questions that we want to address here, but I did want to mention to everyone, we do have another webinar coming up in October where we will do a deep dive on the field workflows. We'll give you a more insight on how you can really take advantage of that scalability to leverage technology wherever you are in your business and make use of some of the advances that we've seen over the last few years, not just with visual positioning, but with tilt compensation and so many other things that have emerged over the last few years. So look for that in your follow-up email that will go out tomorrow. I've also posted a link right there in the chat box if you'd like to go ahead and sign up right now. Tim, do you have any other questions that we should address, or Ted maybe, that you've seen come through? There have been so many questions coming in.
Yes.
I think these guys are having trouble keeping up with them.
Yeah, no, it's been pretty active here. One of the things is comment that just came up now is, would this be a good solution for stockpile volumes? And yes, we've actually got some nice examples that we'll probably be showing in some of the future webinars that do show some of that. There's been a lot of, there was a question here on, is there a boot for the bottom of the pole for rooftop acquisitions? And you could put a boot on the bottom of the pole. When you're taking the images, you're holding the sensor above anyway. You're not jabbing the point into the roof. The only time that would be an issue is if you were locating a discrete point with the pole itself, and then you would have to use some care or have some sort of a rubber stopper or something like that on there. Ted, what else are you seeing here?
We can get a topo shoe, and there are other rods available, so
Yeah.
absolutely.
Is the imaging in Captivate standard or an option for the same and the same for Infinity? That's a good question. When you have the GS18 I and that's interfaced to it, the imaging portion does come up. If you hook other sensors, then that portion does not come up. So it's included in the Captivate solution. Infinity, there's 3 levels of solution. The first of which would be the Infinity Basic, which allows us to import the data, report on the data, and then export that type of data. So we've also got reporting. So we're documenting our surveys. The second level is the ability to create the points, which is what Bob was showing in the video earlier, where we were selecting the points to locate the catch basin, that type of a thing. And then the third level would be the point clouds from the images, where we're actually computing our dense point clouds and carrying it on from there. So
one question I've seen come up a few times is, are there any limits to the image groups that you can capture on a project? Does anybody have to be concerned about the size of their project or how long they're out in the field before they have to dump their data?
So it depends upon what collector you're using, but even the CS20, which has more limited space than the CS35, has 4 gigs, plus you can put external storage into it. So you should be good and disciplined in cleaning your data, but you can go out and capture several days and probably weeks of data without having to worry about overloading your collector.
Well, and there's a best practice to follow there too, right? Like when you're done at the end of the day, you really should offload your data. Isn't that general best practice?
It's a best practice to get that into your software, do your QA, QCs, and it's electronics. Nobody knows when something's going to happen, and you don't want it to happen to your data. So the quicker you get that backed up and safer you are, it is, definitely a best practice to download regularly and then remove jobs when you haven't been to them. One of the great things with Captivate is you can back up the entire job, and even if you do an update to Captivate, you can reinstall that exact same version. So there's none of this, it doesn't accept an older version. So the DBX raw data can be brought in even if you've done upgrades. So it's really easy to archive our file formats for perpetuating forward or using later.
Okay, and I think this one is kind of related, and that is the amount of time that you can capture. I know you guys were out for 3 days, weren't you, capturing data, and you didn't run into any limitations?
Not at all. With that, there is a single image group can only be 60 seconds. So I don't know that we stated that earlier, but you can capture as many image groups as you want or need, but a single image group will be captured at no more than 60 seconds. It'll automatically stop. You do have to maintain, because it's part of the system, you need to have full GNSS corrections the entire time. So you need to be initialized, and your IMU has to be initialized while you're collecting that image group.
Okay. Ted, have you seen anything come through that we should address? I know we're all trying to keep up with the questions. There are a lot coming in. Thank you. First of all, I just have to say thank you to everyone who took the time either before the webinar or during the session today to ask questions, because we really wanted this session to be valuable for you. So hopefully it has been. Again, I do encourage you to sign up for the next webinar. Tim, did you have something?
No, Ted, there is one question in here, and I was listening to see if it was going to be addressed. And it goes without saying. I mean, they're asking, is the eye also has the tilt in it, and it does. The tilt is in both the T and in the eye. It hasn't been brought up, but I see a couple people asking it. So
Yeah, so it can do, the eye can do everything that you could do with a T plus capture the image group. So you don't have to be using this sensor to only, you can still do stakeout with it, you can still do your topo, you can create those regular points, you can create lines and do everything else that you've done in Captivate with the GS18 with the eye. And then in addition to, you have the imaging capability.
Here's a good question that I've seen come up several times also, and that is the speed at which the data can be collected. I know in the video that we showed at the very beginning, we showed someone walking around an area where they were collecting the data. Is there a limit to the speed? Could it maybe be put on top of a vehicle?
So no, this is not a reality capture tool. And there is a component to both the field of view, so how close you are to an object and how fast you should be moving, because you need to have the object that you're going to capture or the feature inside of that image captured in multiple images. So we're capturing an image every half a second, and we need to have the feature that you would like to extract in an image where it's in front of, aligned with, and behind at a minimum to get good geometry on that. So it is a feature. The speed that you're moving is walking speed is recommended. If you get closer to something, you have to back that down a little bit. As you move away, you can speed it up just a little bit because of our field of view. So we will have the geometry and that object in multiple images, and we can be moving slightly faster.
Okay, and just for point of clarity, you can actually take the 18i and go alongside a ditch and as built a pipe inside a ditch. Is that correct?
That's correct. The camera needs to be pointed to the side of your direction of travel. So if you're moving laterally along a ditch, you're collecting the image off to the side, and you can tilt it as long as you can maintain a good initialization of your IMU through movement and your GNSS initialization. You can point it down in a ditch and walk that and document it through dense point cloud or collect those discrete points.
And that's where we're really seeing a lot of those safety benefits, because if you can get people up out of those ditches, out of those trenches, that's huge.
Out of roadways, away from edges of rooftops, all those safety components are just so clear with this solution.
Yeah. Okay. Another one that's come in here is our good friend Shelby has asked, can the data be post-processed or is it real-time only? And that's kind of a twofold answer to that, because we can create points once the image group is acquired and compiled directly in the Captivate in the field, or we can do that in Infinity after the fact as we brought it in. It's the same processing kernel for point creation in both cases. The point cloud, if we're generating the dense point clouds and we want to go to the next level and generate those, then that is certainly an office processing capability. So hopefully that helps clarify that.
Tim, he's asking if you can do it with, if there's no RTN post-processing.
Oh, okay.
So you have to have an initialized RTK. So you can use SmartLink. So we need to have a correction service though. Okay. It could be RTK network, or it could be PPP, the SmartLink.
Or base rover solution as well. Sorry about that, Shelby. I took your question out of context.
I've seen several people ask about tilting the pole, and is there any limit to how much the pole can be tilted before it goes out of plumb?
So a tilted pole is naturally going to be out of plumb, but it's inside of the compensating range of the IMU. If we go over the 30 degrees, it does create slightly more potential error in the IMU, but that's all displayed in your quality that is on your image group quality. So you're informed of that to know to expect a lower or higher, or if it's good enough for the case that you're collecting the data. That's really what most of this comes down to, is what are you delivering and how accurate did that need to be done? And that's what makes every decision, whether we're doing a traverse and a network adjustment with a total station, whether we're using LiDAR data, whether we're employing drones, whether we're allowed to use GPS, whether that GPS can be through a network or base rover, or it has to be static. All of these are just constant components of the discussion that surveyors are having with their customers as the requirement for the deliverable. I mean, that's what they're essentially service providers, and that's what they're managing and doing. And it is another conversation or another component of that conversation, just like the rest of the tools in your toolbox.
Now, Tim showed us earlier an overlay with the GS18 I imagery and the MS60 point cloud data. I assume that's something that we can do within Infinity, where we're bringing in different data sets and Infinity can combine those. Can you do that with multiple sensors, not just point clouds and photographs?
Absolutely. Infinity can take everything from digital level data to your GNSS, to your total station, to point clouds created in others. We can merge those, we can QC those, and then we can create different deliverables in other file formats to take them into other solutions to expand upon them.
And it can take drone data as well, right?
Absolutely. It's actually the exact same module inside of Infinity. So the dense point cloud from images will allow you to create dense point clouds either with drone data or the GS18 I. So either sensor is using the exact same module and engine to create those point clouds.
Okay, here's a great question about the number of images, because you're talking about image groups, Bob. Is there a minimum number of images that are needed to get that quality that you need? Will a stereo pair work, or is more required?
No, and see, that's where we're not collecting in that same way. We have, each image has its 6 degrees of freedom. So if they're far enough apart and I have the field of view to have the same object captured, I can create a point from that. But ideally, you're going to want it in at least 3 images, especially since many times our images or our position of the camera sensor hasn't changed much. So that's going to be a component of it as well. If I only move a real minor amount in that next image, then that pair is probably not going to provide enough geometry to create that point. I need more. To increase my strength of figure, I need a longer baseline between the 2 images.
Okay, excellent. At the very beginning, we talked a little bit about the operating vision distance and the range of precision. Could you just remind us again what that distance is, the recommended distance to capture good data with the GS18 I?
Absolutely. So we're looking at the 2 to 10 meters. So the 6 to 30 feet is the distance from the sensor to the object that you want to capture. And then the component to consider of that is that's going to change the field of view, just like anything else. So, and then that field of view is going to dictate how fast we can move past that object and how many images we need to be able to extract features from that image.
Okay, excellent. All right, I think we're just about getting to the end of our questions. I know that the guys have been really busy behind the scenes answering a bunch of these. Do you see any others, Tim, that we should mention? I think we've addressed most of these, I believe.
One just came in, can we stop an image group cross the street, for example, and then shoot in the same image group? Typically what you would do is stop the one group, let it compile, and then cross the street and start a new group. The groups are not combined in the field, but if need be and it is appropriate, they can be combined in the office.
Okay, excellent. Well, thank you so much to our panelists today for addressing all of these excellent questions. Thank you for those in our audience who took the time to ask questions. I hope that we've been able to give you a better understanding of what GNSS with integrated visual positioning could mean for you and your business. Again, I do encourage you to sign up for our next webinar, October 29th. You will be receiving information on that within the next few days. And if you get a chance, go ahead and stop by our Pure Surveying website. We do have a lot of very informative stories and blogs at our insights section of puresurveying.com. As you exit today's webinar, please take a moment to fill out a survey that should pop up on your screen. And if you have any questions, don't hesitate to reach out to any of us after the webinar. Thank you so much, everyone.